For 300 years, physics ran on a hidden assumption. Newton's laws worked beautifully, predicting the motion of cannonballs, planets, moons, but buried inside that math was a quiet premise that influences could travel instantly, that if the sun vanished, Earth would feel it now. That cause and effect was stitched together with no gap at all. For everyday speeds, nobody noticed the problem. By the end of this video, you'll understand why nothing in the universe can happen instantly, why space and time are secretly convertible currencies, and why a 19th century physicist accidentally discovered the tempo of reality. But while Newton's universe ran on invisible threads pulling instantly across space, a quieter revolution was already brewing. Scientists were playing with magnets and wires, and what they found would crack that hidden assumption wide open. We've seen the modern examples. A moving wire in a magnetic field pushes electrons, creating an electrical current. That simple idea unleashed the electric revolution. We once thought electricity and magnetism were separate forces. Now we know they are one and the same. And if a moving magnet can create an electric field, then a moving electric field can create a magnetic field. But if they create each other, why can't they oscillate? Electric fields birthing magnetic fields, birthing electric fields, on and on, perpetually, forming a wave. Around the time of the American Civil War, a mathematical physicist named James Clerk Maxwell took Faraday's work and calculated the velocity of that wave. What he found was one of the greatest breakthroughs in all of science, and the velocity matched the speed of light exactly. And in that moment he realized, this wave is light. Maxwell wasn't hunting for a speed limit. He was trying to solve a different puzzle: how electricity and magnetism, two forces that seemed separate, kept influencing each other in strange ways. A changing magnetic field created an electric current. A moving charge generated magnetism. There had to be a deeper connection. So Maxwell did what physicists do. He wrote equations. He unified the two forces into one elegant framework. And when he examined what he'd built, something unexpected stared back at him. His equations only worked if there was a ceiling, a maximum, a specific speed beyond which nothing could signal, nothing could push, nothing could cause. And that number emerged from the constants of electromagnetism itself: 299,792,458 meters per second, the same speed we measure for light. This wasn't coincidence, it was a crack in the old worldview. Light doesn't travel at this speed because light is special. Light travels at this speed because it has no mass, nothing holding it back. It moves exactly as fast as causality allows. At the maximum rate, the universe permits any influence to propagate. And here's what that means. Space-time is stitched together at this speed. It's the thread that holds the fabric taut. Between every cause and every effect, there's a minimum delay, not because of slowness, but because that delay is written into existence itself. Causality propagates. It never arrives instantaneously. The universe preserves order this way. Without a speed limit, effect could precede cause. Answers could arrive before questions. Reality would collapse into a single undifferentiated moment, where everything happens at once, everywhere, with no sequence to give it meaning. But that's not what we have. What we have is patience, cosmic patience built into the structure of reality, a pause that keeps existence from collapsing into immediacy. The speed of light isn't a speed at all, it's a tempo, the rhythm at which the universe allows itself to unfold. And there's one more thing Maxwell's number reveals. Because this speed is constant for everyone, not just measured the same, but fundamentally the same, regardless of how fast you're moving, it acts as a kind of universal exchange rate, a conversion between two things we thought were completely separate: space and time. 1 second of time is fundamentally equivalent to roughly 299,792,458 meters of space. They're not just connected, they're convertible. The speed of light is the rate at which you can trade one for the other. Maxwell never knew the full weight of what he'd found. He died in 1879, 26 years before Einstein published special relativity. But it was there in his equations the whole time, waiting for someone to see what it meant. A universe with a speed limit, a cosmos that takes its time. If this gave you something to sit with, I'm glad you were here. Subscribe if you want to do this again. I'll see you next time.